Hello, everyone. This is Mr. Taylor with Young Engineers. Today, we're going to look at catapult development. Composite bow temporarily meets its limits. Developers must now turn to fundamental difference, ways of storing elastic energy. This path led to the Torsion Catapult. This is part 3 of our catapult series. Torsion Catapult. Torsion Catapult development occurs over a series of discoveries and advancements starting in the mid-4th century BCE. By the end of that century, we end up with two weapons called the Euthytone and the Palatone, the Palatone being a throwing weapon. Here are the images of both of these. And they weren't using torsion springs. Much of the hardware looks the same as traditional catapults, ratchet, trigger, windlass, etc. What's new are the vertically aligned torsion springs. We're going from horizontal to vertical here. Torsion is the twisting of a beam or structural element. Now, torsion springs become the primary storage for elastic energy in this device. What was used primarily storage before was the fact that you had used wood and rope. Torsion springs and a palatone consist of bundles of rope with a wooden arm thrust through the center. All right. Now here are images of the torsion springs. Here's the breakdown of the torsion spring. One look of this device with the bow. As you can see, the bow is pulled back for firing. All right. That video will be posted on Edmodo. All right. Now, how powerful were they? There are reports of arrow shooters that could shoot 200 yards and Roman ballistas that could throw 200-pound stone balls 400 yards. Now, think about this. We're talking football fields. You could take a 200-pound stone and launch it football fields, all right, to put it in perspective. Then we built the Pen Ballista during class, and you can find that on page 190 in your text, which is the Mini Weapons of Mass Destruction, Volume 3. Now, there are some ramifications that took course here. These torsion catapults were so important for city defense, walls were made thin to support arrow shooters on the inside. Furthermore, the design of these machines led to huge strides in math and engineering that helped not just in the military sector, but transferred to the civilian sector as well. As engineers grew to better understand the mathematics behind their design, impressive developments occurred, including the following. These three advances in catapult technology. All right. Now, which leads us to our final part of catapults is the traditional catapult. Mangonel, excuse me. And we finally get our traditional catapult, all right, which is what we also know as the bucket catapult, which is torsion powered by the rope being twisted, and then having your winch tighten back and it will launch the bucket forward. Now, the thing about this traditional catapult is that these were actually less efficient. However, they were simpler in design and made them easier to build and maintain. Catapults were used into medieval times. Ladies and gentlemen, the fact that the Dark Ages took place, there were multiple occurrences of plague and disease, as well as just human greed and warfare. We lost a lot of math and science through time, and also you got to look at the efficiency of moving a military and how you can transfer these weapons. They're all things you need to take into consideration. Now, traditional catapults work through using stored elastic energy by twisting and stretching ropes into a bent wood arm. Use to vault its mass into the air. Now, think about bending a spoon back and launching your peas across the table. Let's not play with your food, boys and girls. All right? Now, here you have an armored catapult. I believe this is on page 90, but I might be incorrect there. Then you have your metal hanger catapult. If you do make the metal hanger catapult on your own, please use adult supervision. You're going to need some type of metal snips or wire snips or cutters to break up this metal hanger, which could cause sharp edges. Then the auger is a very similar traditional catapult, but instead it's using a sling. Okay. And then lastly, here's a catapult simulator game. Try changing these factors, which is the one of them being the density, which is the half moon looking shape. Here, the multitude of stones you can throw, what they're made out of. All right. Now let's change over to the Trebuchet. Okay. Similar to the catapult, Trebuchet launches a projectile from a sling on a pivoting beam. Okay, as you can see in the image. The first catapults designed by the Greeks and Romans date back to the 4th century BC. But at the same time, traction trebuchets originate in China and date back around the same 4th century BC. Here we'll be focusing on counterweight trebuchets, first designed in the 12th century. Descendants of the first Chinese trebuchets, these siege weapons resulted from advances by Islam and Byzantine civilizations, further development in Western Europe. If you look at history, we're talking about the Silk Road here, that's connecting Asia, the Middle East, and Europe for trade, but we don't always just trade goods in society and civilizations. We trade ideas, culture, education, etc. And this has been going on throughout time, including today. Now, how do they work, these trebuchets? A counterweight rotates the beam through an arc that releases the projectiles. You can see here in this fixed counterweight right here. The trebuchet, the counterweight is hosted into air and is held into place, usually by a release system attached to the opposite end of the arm. You have your counterweight and then your release system. Now let's break this down even further. When this release system is activated, the counterweight drops, swinging the arm with a sling attached. Furthermore, the sling follows its arc. One end is released. Now, what I want to start to point out is that right here, part of this sling is attached, and the other has a ring that's hooked. Now, as you can see here, once you get to a certain point, the ring discharges, it's released, and it slings this projectile forward. Okay. Now, one of our last points, can you guess some of the main factors that affect trebuchet performance? Major factors to consider, as you can see here: counterweight mass, counterweight height, projectile mass, sling length, launch angle, wheels versus hinge, counterweight. All right. We will continue trebuchets next week. Well, thank you, and this is Mr. Taylor with Young Engineers of Today. Take care. Bye-bye.